You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we examine how encryption protects data on mobile devices and within mobile applications, with smartphones and tablets playing a central role in both personal and business communication. Securing the data they store and transmit is essential. We'll explain how encryption is used on mobile devices, discuss app-specific encryption features, and provide examples that support your ability to recognize encryption use cases on the Information Technology Fundamentals Plus exam. This topic is part of Domain 6, which covers encryption and device protection. You may be presented with a scenario describing an app that locks sensitive notes, or a backup that requires biometric verification. The exam will not test your ability to configure mobile settings or develop secure apps. Instead, your task will be to identify which features demonstrate encryption in use and how they contribute to the overall protection of mobile and application data. Modern mobile devices now come with full disk encryption enabled by default. This means that all data on the phone, including system files, personal data, and app content, is stored in a way that cannot be read without proper authentication. Full disk encryption activates automatically on many Android and iOS devices once a passcode, fingerprint, or other unlock method is set up. This feature helps ensure that if a phone is lost or stolen, its contents remain protected. Examples of data protected by mobile encryption include text messages, photos, and saved contacts. Emails downloaded to the device, along with app-related content like saved passwords, offline documents, or note entries, are also encrypted. When this data is stored on the device, it remains unreadable to anyone who doesn't have the unlock credentials, even if they remove the storage chip or connect the phone to another system. Some applications go a step further by using their own app-level encryption. This means that even within an encrypted device, certain apps secure their data separately. These apps may require a second layer of authentication using a PIN, password, or biometric scan. Without this verification, the app will not decrypt the data it contains, even if the phone itself is already unlocked. This provides an extra layer of protection, especially for apps that handle highly sensitive data. Encrypted messaging apps are a common use case for end-to-end encryption. This type of encryption ensures that only the sender and recipient of a message can read its contents. The message is encrypted before it leaves the sender's device and is only decrypted when it reaches the recipient. Examples of apps that use end-to-end encryption include Signal, WhatsApp, and Apple's iMessage. These platforms do not store readable copies of messages on their servers, enhancing user privacy. Encryption is especially important for mobile devices because they are portable, often connected to public networks, and more likely to be lost or stolen than desktop computers. Phones now hold vast amounts of personal and business data, from contact lists and calendars to payment information and work files. Encrypting this data helps ensure that confidentiality is maintained and reduces the risk of compliance violations in workplace environments. Applications often sync user data with cloud storage services, and this data must be encrypted during both storage and transfer. When app data is backed up to cloud platforms such as Google Drive or iCloud, it is encrypted to protect it from unauthorized access. This protects files at rest on the cloud servers, and encryption protocols like HTTPS protect data in transit during uploads and downloads. The ITF Plus exam may describe these services and ask how data is protected at each stage. Secure access methods like fingerprint scanning, facial recognition, and passcodes work with encryption to restrict who can unlock a mobile device or application. These features provide a gateway to the encrypted data, but do not replace the encryption itself. Even if biometric or password authentication is successful, it merely unlocks access to the encrypted data already in place. This layered approach helps reduce the risk of unauthorized access. Users may also see behavior that shows encryption is active. Apps might display messages like, "This content is locked until you authenticate," or "Backups are encrypted using your Google account." Notes or files marked as secure often require an extra password to open. These prompts are clues that encryption is being used to protect specific data. On the ITF Plus exam, these examples may appear in question descriptions and will help you identify where encryption is applied. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Encryption protects many types of sensitive data stored or processed in mobile apps. This includes login credentials, credit card and payment information, health records, private messages, and personalized settings. Some applications also store user profiles and other content, such as saved documents or images, which may be encrypted depending on the app's design. Whether stored on the device or synced to the cloud, this information needs protection against unauthorized access or data theft. In most modern mobile platforms, encryption is enabled by default, and users don't have to manually configure it. However, some apps provide options for users to enable or manage encryption features in the settings menu. For instance, a secure notes app may allow you to turn on password protection or biometric access. While the ITF Plus exam will not test your ability to change these settings, it may include questions that ask you to recognize that such options reflect encrypted storage. Cloud backup services used by mobile devices also apply encryption to protect saved content. Backups stored on platforms like iCloud or Google Drive are encrypted both during transfer and while stored in the cloud. Accessing these backups usually requires account credentials or device-based keys. If a device is wiped or lost, users can safely restore their data knowing it remained protected. The ITF Plus exam may describe encrypted cloud backup behavior and ask you to identify what is being protected and how. Mobile device management, or MDM, may also appear on the exam in the context of business use. MDM tools allow organizations to enforce encryption and other security policies on company-issued phones and tablets. For example, an employer may require encryption to be turned on, prevent data from being stored on unsecured apps, or enable remote wipe capabilities. Although the exam does not require deep knowledge of MDM, it may reference these practices in enterprise-related questions. There are also clear boundaries on what the ITF Plus exam will not include regarding mobile encryption. You will not be tested on mobile app development, how to code encryption, or how to manage mobile file permissions. There will be no requirement to navigate device settings or manage encryption keys. Instead, the exam will present examples of encrypted behavior or outcomes, and your role will be to identify what encryption is protecting and why it's used. One key exam concept is the ability to distinguish between secure and insecure app behaviors. Secure apps typically require a login, request authentication before opening sensitive files, or include visual cues like lock icons or warning banners. Insecure apps may store data without protection, fail to log out users, or allow access without proper credentials. The exam may ask you to choose which app scenario best demonstrates responsible use of encryption. Indicators of mobile encryption are often easy to spot. Users may see security settings referencing encryption status or apps labeled end-to-end encrypted in App Store descriptions. Devices may also include a section in the security or privacy settings confirming that full disk encryption is active. These cues help users understand that encryption is in place, even if they don't know the technical details. The exam may include these indicators in question prompts. These mobile encryption practices connect directly to the encryption principles covered in Episode 88. Data at rest, such as local app storage or backups, is protected with encryption while stored. Data in transit, such as chat messages or file uploads, is encrypted during transmission. Understanding how these two forms of protection apply to mobile platforms reinforces the broader importance of encryption across all digital environments. The reason this topic is included in the ITF Plus exam is that mobile devices have become common entry points for data breaches. They carry both personal and business data and are frequently used in less secure environments like public networks. Recognizing when and where encryption is applied on mobile platforms helps users make better security decisions. It also builds foundational awareness for roles in IT support, cybersecurity, and user training. To summarize, encryption on mobile devices protects stored files, application data, and cloud backups from unauthorized access. App-specific encryption features secure sensitive content using passwords, biometrics, or account keys. End-to-end encryption is used in messaging apps to protect conversations. The ITF Plus exam will test your ability to recognize these scenarios, not to configure them. Understanding how apps use encryption improves both user safety and exam performance. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.